Hello, welcome to today's talk on Galaxy GameDev, bringing high quality gaming experiences to mobile. Before we start, I'd like to introduce myself. I'm Mike Barnes and I head up the game ecosystem team at Samsung Research UK. Today I'll be providing you with a brief introduction into Galaxy GameDev and how we support game developers to achieve the best possible gaming experience on Samsung devices. I will then discuss the challenges faced when developing games for the mobile environment, and I'll also be talking a bit about an exciting partnership that Samsung have with Google. Finally, I'll discuss optimization work that the game dev team have done on Wild Rift, which made it possible to run on a mobile phone. This will mainly cover Vulkan optimizations and adaptive performance. Let me introduce you to Galaxy GameDev. We work with our partners to optimize their games for mobile devices through the promotion of best practices and the latest tools and technologies such as Vulkan. We also provide code level support, and we even send engineers in-house to work directly on their live game. On top of this, we also work with the biggest game engines, and we make contributions such as adaptive performance, which is something I'm really excited to talk about later in the presentation. On top of this, we work closely with Google to further develop the Android platform. Before we get into the technical optimizations we did on Wild Rift, I'd like to talk to you about the challenges faced when developing a game for the mobile platform. Three of the biggest limitations with mobile form factors are temperature, battery and performance. The mobile device will trigger an immediate reaction to deal with high surface temperature by throttling chip frequencies, which will naturally reduce the performance of the game. Unfortunately, this is something that's very hard for developers to anticipate at runtime, and there's very little they can do to prevent it from happening. In this example to the right, we can see that thermal throttling starts at around 3 minutes, where the temperature continues to increase and the clock frequency lowers along with the FPS. This will create a much worse gaming experience. Battery power is another limitation of mobile form factors. Without a continuous source of power, we have to consider the power consumption and the effect that this will have on the user experience. Whilst mobile computing power has come a long way in recent years, it is still a long way behind the likes of desktop PC and consoles. There are further challenges when developing content for mobile. We are also seeing more games pushing towards console-like experiences which demand higher frequencies and much better visual effects. How can Samsung respond to these challenges? Samsung provides a game booster and game plugins that allow users to provide system-level optimizations to improve the gaming experience. We also provide optimization algorithms using AI and machine learning technologies. This taps into big data to assist with the performance optimizations. In this presentation, we will be focusing on partner collaborations and how Samsung work with partners such as game studios, game engines, Google and chipset vendors to overcome these limitations of mobile development. Samsung is making every effort to develop deeper partner collaborations. Firstly, we are strengthening the technical support of game developers. In addition, Samsung is also actively contributing to the development of Khronos' Vulkan graphics API. We are also collaborating with game engine makers to add new features such as adaptive performance, which not only improves the performance of the game, but it also improves the developer experience. On top of this, we are strengthening our collaboration with Google in many ways to improve the Android gaming platform. Lastly, Samsung is optimizing drivers with game vendors to improve game performance. Here we are going to talk about Samsung's partnership with Google on the new Game Mode API, Game Mode Intervention and Angle project. Here we can see how Samsung and Google are partnering up together to improve game performance in Android. Samsung is already adopting game mode APIs for Android 12 and has a lot of data to influence further interventions and OS improvements. Google share the following to Samsung: Android Development Kit, OS Performance and Power Optimization, Game Ecosystem, and in return, Samsung shares to Google the following: gamer insights based on field metrics, game optimization solutions, and device features per segment. With this collaboration, the two companies are able to create a win-win situation for each other. Now, let's talk about the Game Mode API support and the Game Mode Intervention support for Android S OS. Firstly, gamers are able to express their preference for performance or power savings. Secondly, game developers can then use Android Game Mode APIs to react to the user intent by adjusting their games accordingly. Thirdly, game mode interventions can be used to improve the performance when the APK cannot be modified. Android do not provide these standard APIs to game developers, and OEM vendors usually provide these in different ways, which can cause fragmentation issues. How does this solution help prevent fragmentation issues? Firstly, this will provide standardized ways for developers to react to user preferences for performance or power savings. Secondly, it will result in codifying interventions across the entire ecosystem. Samsung is actively contributing to Window Manager to improve the back buffer resizing intervention. Samsung also supports Angle as a method to improve game performance. Angle is a native GLES library that sits on top of native Vulkan drivers. Angle combines the developer convenience that you get with OpenGLES and the performance improvements that you also get with the Vulkan API. This allows us to intervene at much lower levels of the graphics stack. Some games see GPU performance improve by up to 15%. Angle improves performance with less effort and better ecosystem alignment. Here is a quote from Tian Lim, who is a VP at Google Play and Android games. Samsung's integration of Android 12's game mode APIs and game mode interventions enables new ways for gamers to optimize their performance. We are pleased to continue partnering with Samsung on R&D efforts to further improve Android gaming. Here we are going to talk about our collaboration on the hugely popular League of Legends Wild Rift and how we were able to help them optimize this game for mobile. Before I get into that, I'd like to give you a sneak peek of what we've been working on. Bringing Wild Rift to mobile. I'm going to talk you through the optimization work that Galaxy GameDev did on the famous multiplayer online battle arena game, League of Legends Wild Rift. Our aim was to maximize the performance of the game on mobile, whilst keeping the same quality as the PC version. To achieve this goal, we worked closely with the Wild Rift development team. We helped them to optimize a Vulkan implementation in Unity, including fixing any compatibility issues to make sure that there were no problems when running the game on mobile devices. And finally, we integrated adaptive performance, which enabled us to achieve up to 120 FPS, which is an incredible amount of performance for a mobile phone. Vulkan is a next-generation, low-level graphics API with explicit control and minimum CPU overhead. What's good is it's already available in most game engines. Today, we want to talk to you about the best practices for using Vulkan in mobile games. Firstly, let's talk about Vulkan object caching. As some of you may know, Vulkan is handle-based rather than state-based. This means that all states are stored in specific objects. Most of them are immutable, which is perfect for caching. Here is a list of recommended candidates for object caching. The descriptor sets and the render pipeline in particular will see some of the biggest savings in the CPU and memory resources. This is because you'll be swapping them often. According to the Vulkan specification, different objects may share the same handles. Here you can see a memory buffer and image object all have the same value. But what's more important is that these handles can be reused after an object is destroyed. Here, buffer 13 was destroyed, then another buffer was created with the same handle. So if you use handles for caching, you need to be very careful and remove all dead entries. Additionally, this dead object tracking may have such a high CPU overhead that it will make the cache inefficient. A better solution is to assign unique IDs for each object. We recommend to implement this by declaring a class that both contains a handle and a unique ID. Unlike handles, when using IDs, dead entities cause no harm and don't need to be tracked and removed individually. This allows you to use a much more efficient garbage collector. Avoid using some sort of global map that needs to convert handles to IDs. This will add significant CPU overhead, and it will not work with dead handles anyway, because they will need to be removed from this map. Another basic optimization for Vulkan is one that we like to call primary command buffer synchronization. In Vulkan, we have two types of command buffer, primary and secondary. The secondary command buffer can store a fixed sequence of commands that can be reused in every frame. The problem is, in actual games, there are rarely such sequences. We need to record commands for every frame, so why waste the CPU time? So why not just record them into the primary command buffers? So here we can see that in the optimized case, we use a single primary command buffer for each frame and submit it to the GPU for rendering. Another important thing for the frame sync up here is that in most Vulkan tutorials, after submitting the primary command buffer, in every frame there is a wait for fence. But this is really not necessary. Assuming that we have 3 consecutively indexed swap chain images, then for frame n, we only need to check the status of n2 frame, and wait only if it hasn't finished presenting yet. This will effectively reduce the number of wait for fences. Okay, now we can move on to game-specific Vulkan optimizations. In most games, it is often required to pass new uniform data for each draw call. To do this, we allocated a separate large buffer to be used as a ring buffer. From above, we know we have a fence, so we can assign a fence for each frame to track down when the GPU is done using the buffer's memory. As an example, here frame 42 is writing to the ring buffer. Frame 40 and 41 are still using the buffer, so their fences have not been signaled yet. But frame 39 has already finished on the CPU, so its fence has been signaled. So this memory is safe to be reclaimed once the buffer runs out of free space. But if there is no more free space, just replace it with a bigger one. Create a large enough buffer to always have free space. Next, we want to introduce the most important object cache for Wild Rift, the descriptor set cache. In Vulkan, you need to use a descriptor set object to pass resources to shaders. However, updating descriptor sets for each draw may be very expensive. As a result, we decided to introduce a descriptor set cache to reuse the already updated descriptor sets. With an efficient implementation, there were nearly no new update calls during any given battle. Also, as mentioned at the beginning, do not forget to use generated IDs instead of handles for descriptor set keys. It is better to combine the updated descriptor set where possible, as it is more efficient than using a single update each draw. Also, here are some useful tips for reducing the number of descriptor sets. There are 2 types of descriptors for uniform buffers, normal and dynamic. With normal update buffers, to specify offset into the same buffer, you need a new descriptor set per each draw call. But with dynamic uniform buffers, you can use a single descriptor set for multiple draw calls. Final offset is calculated by the sum of the base offset inside the descriptor set and the dynamic offsets in the bind commands. Dynamic uniform buffers are the first thing you should implement before moving on to descriptor set caches. Otherwise, the hit rate will be so bad that nearly every cache access will be a cache miss. Now let's talk about the barrier optimization in Wild Rift. Developers are able to define their own GPU to GPU synchronization points between pipeline stages using pipeline barriers. This is a powerful feature of Vulkan, and it helps developers minimize the sync-up cost of the GPU. The barrier optimizations of Wild Rift mainly contain two parts: using barriers correctly and batching barriers where possible. Firstly, in the game, some effects needed to use the rendering result from a previous color attachment. The game's implementation would copy the required color attachment to a temp texture, causing a barrier to be placed in the render pass. This is critical for Vulkan because the driver will not know how to handle the barrier properly. So we split the render passes where we run into these situations and place the barrier between them. Additionally, many effects create circular barriers, that is, a pair of barriers transfers an image from read-only to write and back again. Also, we might transfer an attachment to read-only at the end of a render pass to avoid validation errors. The game itself may also generate a repeat barrier at the beginning of the next render pass. These two cases will both waste valuable GPU resources, but they can both be easily identified through RenderDoc. So, now we have proper barriers. The next stage is to batch them together. Barrier batching is a simple Vulkan optimization, where we merge together the stages in pipeline barriers. We batch them together and flush them out before the beginning of the next render pass. In most cases, batching barriers generates better performance and fewer bugs than if we were to generate barrier commands one by one. Now, let's take a look at what we did for explicit render passes in the game. The most important render pass optimization is the removal of empty render passes. An empty render pass is a render pass without any draw calls. This usually happens when the engine triggers any clear commands. Render pass switching is quite a heavy operation, so we are better off removing all of the empty render passes. Our solution was to delay the switching. For example, if the render target hadn't changed and no new draw calls came in, then we can safely assume that no new render pass was needed. And now comes our final optimization for Vulkan. In most games, artists will batch together similar effects into a CG file. This will then generate multiple shader binaries with only slight variations. This can cause some varying mismatches, like the outputs from a vertex shader not being consumed by the fragment shader. This wastes the interpolation of the unused varyings during rasterization. By trying to fix this from the CG file, it can be quite dangerous because you can easily increase the amount of maintenance required due to having lots of similar CG files. As a result, we scanned the final SPIR-V binary to set up a varying table from the vertex shader output. This was then used to scan the consumed varying value in the fragment shader. Now that we know which varying is not being consumed, we can find their place from the table and then remove them from the binary code. The scanning is quite a CPU heavy operation. This is because we need to scan the binary code byte by byte. Because of this, we also need the shader module cache that will store all of the shader scanned modules. The scanning is quite a heavy CPU operation. This is because we need to scan the binary code byte by byte. Because of this, we need a shader model cache to store all of the scanned shader modules. In Wild Rift, we set up the cache with the hash key from the detail shader identity from within Unity's shader compiler. That's it in terms of talking about Vulkan optimizations, but that's not to say we're not continuing to work on optimizations for the game, such as new features like pre-rotation. Hopefully we can achieve even better results through the collaboration in the future. During the collaboration, we ran into many driver bugs and validation errors. First, we're going to take a look at the driver bugs. This is an issue with the Adreno driver. The game used a draw call with color mask none to update the depth information for transparent objects. But on some old Adreno drivers, if there is one pipeline with color mask none, then the blend state will be ignored in the next pipeline. You can see the erroneous triangles in the red box below. In order to solve this issue, we had to force enable blend for the pipeline with color mask none as a workaround. Now let's see the main validation errors we faced during Wild Rift support. In this example, the barrier for image clear was in a different command buffer, so the driver cannot guarantee that it will execute before the present, and this can result in undefined behavior. To fix this error, we forced usage of the same command buffer for swap chain images. The second error is related to MIP level, as some image formats cannot support the MIP size of 1 by 1. To fix this error, we check the minimum block size supported in a format table within Unity. We then stop MIP level generation if we meet the minimum block size. What we can see here is that with our Vulkan optimizations, you're able to achieve a higher FPS, a more stable FPS, with lower temperature, so you'll be able to play your game for longer with lower power consumption. Now we are going to talk about the game engine optimizations. Here we're going to talk about power management, dynamic features, and high frame rates. Adaptive Performance is a collaboration between Samsung and Unity that is available for developers right now within Unity. Through Adaptive Performance, we're able to supply temperature levels of the device and also expose an interface to control the GPU and CPU level at runtime. This enables developers to easily control the device load according to the actual thermal load of their game. We integrated Adaptive Performance through working very closely with the Wild Rift development team. This allowed them to reduce the power consumption and increase the frame rate and the stability. Of course, this deep technical collaboration will help bring Adaptive Performance to more and more game developers and more games as we start to see the clear benefit that this brings. Now, let's discuss how Adaptive Performance works. For short, in the next few pages, we're going to refer to Adaptive Performance as ADP. The first important part of ADP is the Power Manager. ADP Power Manager can detect current performance status and check bottlenecks against current GPU and CPU levels. It contains two parts, Auto Performance Level Controller and Thermal Control. Auto Performance Level Controller works when the temperature is low. At default it is 39 degrees case temperature. The developer can detect the bottleneck of the previous frame and adjust the CPU and GPU levels accordingly. When the temperature is high, ADP will disable the Auto Performance Level Controller and it will apply a thermal control policy instead. The thermal control is from Samsung's Game SDK, and this will limit the highest CPU and GPU levels in order to reduce heat. By using dynamic features, we can adjust the refresh rate of most games and some of the animations. This helps to reduce the CPU load, whilst it also means less power consumption and heat. We can also adjust the detail of the game scene and the characters to reduce the pressure of the rendering load. This will also increase the stability of the game as well as the performance. We also need to check that these dynamic features do not disturb the quality of the gaming experience for the player. These dynamic features are discussed with the game developer and the artist before they are implemented. With Samsung's newest devices like the Galaxy S20 and the S21, we are able to apply much higher frame rates. One of the biggest advantages of using Adaptive Performance is that we are now easily able to add support for higher refresh rates in games. Now let's see how we make this possible. Here are our final comparison results for the S20 Adreno. Through our Vulkan and ADP optimizations, we're able to achieve a nearly full FPS which is much more stable whilst using much less power. The LRP table shows the temperature of the phone case. From this table we can see that both runs of the game started at the same temperature, but after 1 hour of gameplay, with our optimizations, the temperature is still 2.2 degrees lower, with 25% higher FPS being maintained.
That's all from me in terms of the GameDev optimization work that we did on League of Legends Wild Rift. I'm now going to pass you over to Eric from our developer relations team.
Thank you, Mike. Hello everyone, this is Eric from Samsung Developers. I lead a team of evangelists, technical support specialists, developers, social media experts, data geeks, and writers that love working with developer communities. As a game developer, you have choices where your Android mobile games are distributed. I'd like to take a moment to highlight what Galaxy Store can do to help you reach more markets and earn more revenue. Galaxy Store has been on Samsung flagship phones and tablets for years. Samsung delivers a curated experience to Galaxy Store users in 195 countries, including the biggest markets in the world. As a seller on Galaxy Store, you have access to data showing how users interact with your games and runtime statistics to help you understand your audience. You can partner with Samsung to promote your games and find new audiences. With Samsung's in-app purchase libraries, you can increase your revenue in native games as well as those built for popular game engines. To learn more about your opportunities with Galaxy Store and other Samsung platforms, please visit developer.samsung.com/Galaxy Store. Here you can learn how to create an account at the Samsung Seller Office, find useful information on SDKs and APIs, ask questions in our forums, catch the latest updates on our blog, and listen to successful developers and designers on the Samsung Developers Podcast. Thank you for joining us today at GDC. We look forward to seeing your games on Galaxy Store, just like these successful brands have done.